So okay, we will do the 70R loading, and we will do by modeling in the STAAD.Pro 2024. You can download the STAAD.Pro student version from their websites, and you can log in by using any of the email ID, and provide your college ID card so that you can successfully access the download portion. And first of all, we have to configure that something, that is base unit will be metric system and global axis will be y. You can also use z, but the global axis should be y. And then we will create a new, there we named it 70R 70R 1, and hence create. So our first task will be to create the beam. You can see that y axis will be in the upward direction, x is horizontal, and z is perpendicular to the screen. And you can we, in our problem, we will use the 60-meter span, that is two span, three supported 60-meter span, a bridge deck or a beam, and the interval will be 30-30, that is L1 will be 30 and L2 will be 30. So edit, and spacing I can use 30 or maybe 10. And first of all, we create the node point, and we draw this and click over the 30, and again we press the escape button to newly we can add the rest of the portion. And then we will do the add beam section, and we click 30 30. So our process will be towards the this, that is geometry. Then after we will assign the properties. So in property section, I am using a steel section, that is IS beam, and I can use ISMB 600. Add, and then assign to view, that is R1 R2, means two individual sections is assigned. Then we'll jump up into the material section, and in this portion we will use steel. Assign to view, assign. Then specification not required. Then we will jump into the support portion. So there is a lots of support options, but there is not any roller support or rocker support. There is enforced butt, or first of all we will add a pinned beam, that is pin support, and another we will use the we can use the roller support by using the enforced butt via release to the fx direction and my, mx, and mz, that is moment will be 0, only the fx direction the release is there. Add. So then the simply supported in the pin joint will be assigned over here, assigned to selected node. Then we assign this, and then again we assign this type of support, because in bridge deck there will be a thermal expansion or compaction. So there will be a thermal conductivity component, so that the deck will be movable towards the x direction and not induce the stress as much. Okay, then the important things is loading. So here we will use the 70R load system, that is from IRC 6. You will get the load arrangement for class 70R system. So here 8 ton, 12 ton, 12 ton, 17 ton, 17 ton, that load is there. And one thing, that there is a something mistake, that is this will be 0.91. This must be 0.91. It is shown here that 0.61 or something, but this will be 0.91. This is 3.96, 1.52, 2.13, 1.37, 3.05, 1.37, and another 0.91. So this load will be assigned over there, and then we will analyze the beam, and for various load cases there we will get the maximum reaction. Our main objective is to get the maximum reaction forces for this load arrangement, which is called 70R load arrangement. So we will first do the vehicle definition, add, and then one second, first there will be 8 ton. So means here in kilonewton this will be 80, and then the load is 120, that is 12 ton, and the distance between them is from backward, from 8 ton to the 17 ton towards, we will put the distance measurement, that is 80 to 120, there is a 3.96 meter, 120, 1.52, then 17, 2.13, 3.96, 15, 1.52, 170, then 2.13. I am showing this by seeing the IRC code page. 170, 1.37, then 170, 3.05, then 170, 1.37. So 80, 120, 3.96, 2.52, 2.13, 1.37, 3.05, and okay. So we will add this. There is definition will be assigned. Then load case details we will add. First of all, dead load, and then negative y direction dead load. Okay. Self weight, assign to view, assign and then sorry, we will put another, the vehicle load definition will have to be put the add load case details. Then we will go to the load generation. There is load generation 1, that which we will generate it in the vehicle definition section and add in generated portion. So here we used an incremental x in x-axis, that is 0.1, and x coordinate 0. Okay, so the 8-ton load point will be started over here from 0 coordinate. We can also use minus, that is we can put minus 13.4, so that the whole rolling arrangement is to backward to the left portion, but here we will use 0. Add, and here one thing, that is there is the we can here one thing, that is 0.1 division, incremental division will be there, means the whole load arrangement will be incrementally towards the right direction from the left direction by 0.1 meter, 0.1 meter, this like. So here small calculation we have to do, that is our entire beam is 60 meter, so 60 meter divided by 0.1, that is our least count, plus 1, that is 601, plus dead load. There will be a 602 load cases. 601 will be the only the rolling load cases. So 601. So we loading there will be 601 combination, modify, and here we go. The loading part is completed, then analyze portion. Okay, we will generate a report, so we will put all, add, run. Little bit time will be taken, and then as per your computer's configuration the time will be required. Okay, there is no error, 13 warning and 2 nodes. Go to post processing mode. The all load combination, yes, 602, that is 601 plus dead load. Okay, so we will find out the reaction, maximum reaction, that is when we go to the summary portion we will get the maximum reaction part, that is 1065.377. This will be the maximum reaction at node point 219 load case. Okay, so here the small division will be 0.1, hence when the load is incremented to the 219 number of combination, then means 21.9 meter ahead the load will be generated, maximum reaction force will be generated. So there is, we can reaction load view we can change the view. This is the thing. Okay, so reaction, you can see that the load is started from the 0, that is 8. This is 8 ton and this is 17, 17, 4, 17 ton, that this 12 ton, and it is 8 ton. We put the x point is 0, that is lied over the reaction, and then here in the corner of the load portion we will load generation 2 3, that you can see that the reaction forces is developed and generated in this manner as per the position of the rolling load. So we know that 20219 load case will be the maximum, that we can rapidly go to the there 219, there you go. In this portion you can see that y is 1065.377 kilonewton. Okay, so by this we can numerically model this 70R loading, and we can calculate by hand by manual calculation and compare both these things. One thing is noted, that is here we don't able to analyze or run this result if we do not provide any mass to the whole member. That's why we use the ISMB 600. But in our manual calculation we don't use any mass to our beam, so there must be one addition. The maximum reaction is here, the maximum reaction, that is 1065.377 kilonewton is the summation of the, here in manual part we should uh, consider a UDL of the UDL to consider the dead load of the beam in our manual calculation, so that we will match these two things. That actually in our calculation for maximum reaction there will be a value of 97.5 ton something, and when you consider the UDL of for ISMB 600, there will be 1.21 kilonewton per meter uh, load. So then with the reaction we can use the reaction by using only the UDL, and we will get the midpoint reaction, and summation will be the resultant and match, and there is same the approximate approximation will be there, and 1065 will be came out. So the our next part is to generate the report. We can use the picture of this thing, that is we take picture 1, that this is called the maximum reaction, support reaction. Okay, in report part, okay, job information is not that much required because there is load combination of 600 will be there, so no need. We can analytical modeling, post processing, and then after we will click to the picture. Okay, we will deselect all the thing first, then we will select, that is node will be there, beam will be there, section will be there, material quantity by section, support moving load definition, basic load cases, static check no required, node displacement summary not required, uh, reaction summary will be required. Here you can see, and then picture, and picture should be in the fit to full page. That's okay. You will print. Okay, you will get the report. There will node, beam, section, material, the moving load definition, basic load cases, and reaction summary. The maximum reaction will be this, and the picture is this. This is a typical example of simple mechanism. You can, I think it will be helpful for all of you. Thank you.